the sustainability manager at the city of San Luis Obispo. Maybe, I don't know how active folks are right now, but if you could just put like your hand up or give me a little reaction emoji if you know where that is or have been there. A couple. Okay. Okay. We got a whole flood of it. That's great. So we're on the Central Coast of California, about 50,000 people, and have had a real leadership moment with our city council and climate action since about 2018. Been doing decarbonization work across multiple sectors since then. So today we just want to share with you findings from one small case study, but we think that it's really high value transferable lessons. Cool, yeah, Greg, it looks good. If you go to the next slide, I'd appreciate it. All right, so you might ask yourself, why are we focusing on mobile and manufactured homes? We have a number of policy objectives that our community and council have given to us as staff. And one of that is minimizing emissions from new construction through building codes, where the Ninth Circuit, not an obstacle, we would be actively eliminating emissions from new construction through building codes, but we're pretty dang close. And our other core objective is dramatically reducing greenhouse gas emissions through electrification in our existing buildings, both voluntary and regulatory, from a regulatory perspective. And in those programmatic spaces, we have clear direction from our council and community to have a equity focus, to leverage outside funds to the maximum extent possible to benefit our community, and then also to always have a theory of scaling and transformation. A pilot that's just a pilot for pilot's sake isn't good enough. It always has to be part of a larger story about how we rapidly decarbonize while making our community a better place. And so in the halcyon days of 2022, as we were looking around and seeing all of the dollars coming our way for electrification retrofits, we also saw that a lot of those dollars were for low-income homeowners. And so we were like, great, let's go find all the low-income homeowners and create a program that helps them get access to resources. And what we found out in our community, which is 60% renters, so we're already only with 40% of our building stock that's homeowners, and it's a relatively expensive housing market, a hard place to live and own your own home, that low income homeowners, primarily what we were actually talking about were mobile and manufactured home owners and home occupants. And so that was a huge insight. And as we talked to other folks in similar communities, we found that actually that kind of was true in a lot of places. And so next slide, Greg. And so the next thing we said was, cool, we'll go like we always do. We found this thing, a new part of our community to serve. Let's go talk to all the practitioners across our great country and understand how other folks have already solved this problem. And for sure, there are some really incredible folks doing work in this space throughout the US. But the literature was thin, as you might say. And we were kind of surprised to find that for retrofits in our climate zone, for information about how to deal with regulatory issues, mobile home, even simple things like how do tariffs work on master meters and how does that work in relationship to electrification? Like there just wasn't really anything in the literature. So we put together an application for the Department of Energy Buildings Upgrade Prize, and we're lucky enough to be funded. And what we really pitched to the DOE was, hey, let us do a handful of electrification projects in mobile homes in our community, and we'll come back and share out what key characteristics are of this building stock, and then also we'll do some monitoring and performance on the electrification components, and Greg's going to talk about that. So really what I want to share with the rest of my time is some of our findings around manufactured home characteristics, and then talk a little bit about the components of the program that we operated that got us to the findings that Greg will talk about. And manufactured homes, the most important characteristic is that they are exactly the same as stick-built homes in the sense that like people live in them. It's where lives and meaning is made. And so while we are a program that works on buildings, we're a program that serves humans. And so that's always an overriding 1A characteristic of all this stuff, is that we're serving real people that have real lives and need this stuff to be awesome for them. But when we actually broke into like what are the physical what are the constraints, what are the opportunities with manufactured homes specifically? We just kind of bucketed into a couple of categories. And there's a much longer paper that's going to be published as part of the ACEEE summer study proceedings that we'd be happy to link out to go way deeper into this. But at the highest level, from the physical perspective, very different uh, building assemblies, like wall assemblies, are typically quite shallow. There's not very much attic headway, if any at all. And so you just get much less envelope uh, to insulate. There's significant air leakage. And so you're just starting with a much lower performing building, even the new ones, but particularly as you get into older vintages. Many of these buildings are in sub-metered systems that have both from the utility meter to their sub-meter have really outdated electrical systems and significant problems. And then from the sub-meter to the panel and the panel into the home itself just have substantial electrical challenges, and some have service capacity as low as 30 amps. And then particularly and so that's
So,
just the physical side. From a regulatory perspective, it's also quite different in the sense that the building code is not enforced. It's a different part of the code, and it's not enforced by the local AHJ. It's actually enforced in California by State Housing Community Development Department. So there's a whole different permitting apparatus. Um, how these parks exist are just there's a wide variety of park ownership structures, everything from a co-op, all the occupants collectively own the land on one side, to a private capital, um, like an equity owned park, and no one has ever even seen the owner, is not even sure if there's a real human behind it on the other side. And so that really dictates like how much stuff can be done in there. And then because the folks tend to own the building but not the land underneath it, there's also limited financing options. And so even if folks want to make upgrades, access to just basic financing mechanisms don't exist like they do in a stick-built home. The characteristics of the buildings that we worked in, and this is, I think, quite typical in California anyways, they're typically dual fuel, so natural gas or propane, typically have a master meter sub-meter relationship. In California, there's one master metered electrical rate, and it was not designed for full electrification. In fact, I think it's many decades old, and so there automatically are some structural barriers to electrification in this building stock. And then one of our key findings is because of everything I just said, although there are many utility programs from the IOUs, CCAs, the RENs, down to and everything in between to local service providers, et cetera, there's many programs that could serve these folks in theory, but there are particular programmatic, uh, I don't know, like administrative decisions that those program administrators have made that unintentionally make it so they cannot serve mobile manufactured homes. And so there's a real dearth of resources to support this building stock. Greg?
well, there was one question, by the way, Jan. I who I let Jan. Do you want to ask your question? You had your hand up. Okay, well, we'll save that till later. Sorry about that. Continue on.
Great, thanks. Greg, next slide, please. So, all that being true, we really wanted to then say, okay, well, that's the, like, in theory, that's the summary of the building stock, the stock assessment. Um, what would it mean to actually electrify some or all of the loads in a small handful of homes? And so, again, we went to the Department of Energy, asked for resources as part of the Building Upgrades Prize, and were able to receive those. And we looked into the feasibility and cost effectiveness of electrification. We primarily focused on very low income residents, and we covered 100% of the upgrade costs, with the intent of this isn't like a way that we show that electrification is like a cost effective life cycle or anything like that, but rather just like, is this physically possible? And then what's the on bill impact of it? And then to make this an awesome experience for the participants, we offered a bunch of technical support and energy coaching, which I'll talk about later. I do want to talk quickly about our partners in this project. We were able to work with our community action partnership, our regional one. They're already doing federal weatherization work, and then also just basic safety works like slip bars and showers, fixing stairs up to some of the units. And so they had an incredibly positive relationship and reputation within these parks, and also already had the skilled labor on hand to do things like water heater and HVAC replacements. And so they're the core driving partner in this as far as installations go. We also brought in the Diversity Coalition of San Luis Obispo County, and they had won a previous California Tech Quick Start grant to understand how to find value in electrification work across broad constituencies. So basically, like, what's the value proposition for electrification for a low-income community member, someone who lives in a mobile home, et cetera. And they were able to really design a home check-in process that helped our research participants really felt cared for. And then, of course, Greg from Artemisia Energy, who will be presenting later. Okay, go ahead. For each of the homes that we participated with, that participated in the research, CAPSLO, the Community Action Partnership of San Luis Obispo, provided no-cost weatherization, electrical upgrades as needed, and then they all got water heaters, so we had to do some custom builds on water closet expansions, and then we installed heat pump hot water heaters on 4 of them, and various types of heat pump HVAC or window units and the rest. And a couple of key parts of our project here that are important to emphasize is, one, we did energy monitoring for a full year, summer and winter season, just to understand what both like in terms of energy consumption outcomes were. But then we also provided a bill protection program to each of the participants so that we could offset any potential on-bill costs associated with the upgrades. We also provided home comfort check-ins and energy coaching. So, because we're working with a community that some of the folks were older and didn't have access to smartphones or other types of technological equipment that we might be, some of our other constituents might be used to, we really wanted to spend time helping them understand how to use the knobs, how to use the gadgets, how to make sure that the thing was working right. And as we noticed, like, hey, no one's using, or one of our participants isn't using their heat pump at all, really being able to follow up and call them and say, hey, what's going on? Like, is it cold in your home? And they're like, yeah, it is. I couldn't figure out how to turn the thing on. So we were there to help them access the equipment, teach them how to use it properly, and then also hear them when they said they were unhappy with it. One of the cool things about the bill protection and energy coaching program is we also offered a replacement guarantee. So after the research was done, if they wanted us to replace any of their equipment with brand new natural gas equipment, we had budget reserves to do so. And one of the great signs from the research is that none of the participants chose to take us up on that offer. All right, next slide. So that's the conclusion of my portion of the presentation. Just have a couple of pictures on here, some of the outreach events we did and some of the installations in the field. And so I'll conclude my presentation there, and happy to hand it over to Greg to talk about some of the energy and on-bill findings from the research.
Woo woo! Good job, Chris. All right, hey Greg. Oh, we can't hear you yet, but we want to.
That's why I'm just talking to the void. So I'm going to keep this sort of focused, and thanks, Chris. That was an awesome summary. The full paper from ACEEE, read it. Please follow up with questions. Happy to go into more detail on like why we chose the equipment we did, things that we found from it. But I want to kind of focus on some main things and then opportunities in this space. Chris mentioned our research started with the DOE in around 2022, 23, but actually preceded that a little bit. We did a small study on 237 homes at a manufactured home park using like 5 years of just their monthly billing data. And that was kind of an attempt to, model, do the math on like what would electrification look like? Is it going to lead to cost increases? How does that vary depending on disaggregated loads like water heating or winter space heating, to kind of get a sense ballpark of like what this is going to do to bills and energy consumption. And what we found was that it was kind of all over the place, but things weren't really that positive, and I'll talk about that later from in terms of specific bill impacts. But that led to more specific Emporia monitored study on a handful of residents for them in particular. So it's a small sample size, but we had energy coaching happening. We were in very close contact with these people for the most part. And so it's really deep analysis in terms of how people are using their equipment, how that's informing energy use, how that's informing bill impacts, et cetera, et cetera. Four residents, three are double wide, one single wide. Three of them are older, 1970s, pre HUD 70s, or sorry, pre 1990s HUD, after Hurricane Andrew. One of them was newer, so very different. Three of them are owners, one's a renter. We did do weatherization where possible on all of them, although in the 2016 carriage, there's really not a lot of opportunity. So that was anything from window upgrades, duct fixes, insulation under the floor where possible, air sealing, things like that. Two of them got a panel upgrade, and we can talk about panels. We'll come back to that. The equipment we installed, so at the time, this was a few years ago before we had more options for 120 volt integrated or separate heat pump water heaters. So at the time, the Rheem ProTerra dedicated circuit, which no longer exists, was what we chose. And we can talk a little bit about why we chose that, but that allowed us to get good recovery time with the larger compressor. We were able to fit it into a smaller closet. A lot of these don't have large spaces to put a big heat pump water in here, so we're limited to 40 gallon, and we're able to stay on 120 volts and not increase demand substantially. So that was kind of the sweet spot we landed on, and I'll come back to some of the benefits of having thermal mixing valves and being able to do things like increase thermal storage while still having a pretty power efficient piece of equipment. On the HVAC side, three of them got 2-ton ducted systems, pretty conventional. And we put two gradients in resident fours, one in a bedroom and one in the main space. The furnace was still operational, so that was not the primary source per se, but using the gradient as a secondary means of heat. So very, very different approach there. And then resident one got full electrification, everything, cooking, laundry, etc. And we can talk a little bit about that, including plug-in solar, which I'll come back to. So any questions on like the group of study participants before I move on?
Oh, I was only wondering, there's four here, but and that is to be expanded, or is this the limits of how many houses you guys got done?
Yeah, so this was during like the intense study period of a year, before some of our DOE funding was nixed, during sort of like the pilot phase. The number of participants for this current iteration through some tech funding and other funding sources, which I'm sure Chris can talk more about than I can, is in the dozens of people. But this is to scale over time. So we're just focusing on the folks that we have a lot of really good data for from the initial pilot.
Thanks.
All right, so I'm talking about water heating. I mentioned we put in dedicated circuits, so it's like a 1 kilowatt compressor, so close to the heating capacity of what like a standard electric resistance coil would have, 4 kilowatt coil, 120 volts, thermal mixing valves, 40 gallon. That allowed us to deal with some of the uncertainty around hot water use patterns. And what we've learned in the past is that demography matters, and it's really challenging to know how people use hot water and when. And we really want to be conservative. People want cold beer and hot showers, right? I don't know if Amory is here today, but so we're trying to be conservative here with the approach. This led to some benefits, right? So one of our residents was just fine at 130 degrees all winter. It doesn't get that cold and slow, so we don't have to worry about not having a resistive backup. One of our residents does shower and laundry at a very similar time. That's the one in orange there, and so we had to crank it up to 135. So good thing we had that ability. And then resident one, turns out her closet is basically on the other side of the wall from her bedroom, and this is a 1 kilowatt compressor. It's pretty noisy even with the rubber mat and all that. Because we had all this extra thermal storage, we could load shift. You can see that blue peak. Basically had it shut off at night. Never operated once over the course of the year, all night. Never ran out of hot water. And because we had a larger compressor with the dedicated circuit, were able to recover super quickly. So we probably would have been fine with something smaller for her, but we didn't know a lot of this stuff going in, um, and yeah, it ended up benefiting all of our participants in terms of being able to have that extra thermal storage and modulate where necessary. Any questions on the water heater piece of it? Since then, other products like ecological and these split systems that can go down to reasonable temperatures and operate on 120 volts, we've started installing those. So there's a lot more options out there now, but the main constraint here really was closet space that we kind of had to design around. On the HVAC side, this is the one that has the biggest impact on bills, on energy usage, uh, behavior, people not being comfortable with smart thermostats or being used to having 80 kBTU of gas that they turn on and off and on and off. And so there's a lot more behavioral variation in terms of, like how people are using their heat pumps. Um, in general, we got fairly few comments on everybody's comfortable. They also got cooling, even though slow is pretty mild. There was some summer cooling that happened, which is a great benefit for these folks. But you can see this average load shape for the winter performance. It's kind of all over the place. So resident three turned the thing on like 4 times during the entire winter. Resident two just kind of set it and forget it at like 80 degrees or something very high, like the house warm. And so using an order of magnitude more than some other people might. Resident one largely use it kind of to, turning it on and off manually, which, was a bit of a challenge for this equipment, but not a lot of complaints there. And the impact that this had on bills, which I'll come back to in a minute, is really dependent on people's heating needs. Uh, Also note that Resident One is the newer carriage, so where it wasn't really possible to fully weatherize, there are limitations in manufactured housing how much you can do. This is a real concern. So if you are expecting bill increases, maybe there's a limit to how much you can weatherize and how much you can actually close that gap, and that was very real for some of these people, particularly resident two. Yeah, there's more detail in the paper, but any questions on the HVAC piece of it? Oh, and I'll mention on the gradient side, found that worked great. We didn't remove the gas equipment, but we were able to reduce. I'll come back to it, but we were able to reduce costs pretty substantially just by having, in the same way that a mini split would allow you to reduce energy consumption, we have sort of zonal control by having a gradient here and a gradient there, and not running the furnace in a leaky home all night, every night. So there's a case for non-ducted systems, I think, in some of these cases. Questions? I know we're kind of coming up close to time.
This is good stuff. Continue.
Yeah, bill impact. So I'll show a slide here in a second that goes into more detail. And I've got the details of what people had installed for reference on the left there. But in Flow, we have Pacific Gas and Electric for electricity, SoCal Gas for gas. It's one of the few places where those overlap like that. And unfortunately, it's basically impossible to electrify at parity with cheap SoCal gas and expensive PG&E electricity, depending on the rate you're on and some other things, which I'll talk about. But resident one around parity for bill increases, so a small increase. Resident two, the one that used a lot of winter nighttime heating, 35% increase. That's a weather normalized number. And then close to parity for the other two folks. The only person that saved was resident four, who had the gradient, and that was just because reducing the furnace operation substantially saved them a ton of gas. So you can see like $430 in gas a year or something like that is what they saved, just by not having to run it all night. But the bottom line here is that even though there's gigantic energy savings, the utility rates are just not in our favor. And this was a huge challenge for us, that it varies by where you live.
And similar question to others, you maybe didn't have the option of putting rooftop solar in because of the wiring of the place or the rules or et cetera, but any thoughts on like adding a balcony solar array to this, one of those little 120-volt plugins?
Yeah, that's my if I can get to it in 4 minutes, that's our sort of call to action.
Oh, my bad. Keep on going.
No, you're good. No, I thank you. So without going into too much detail here, I'm going to explain this plot. So the orange and blue bars, this shows the dollars per mega BTU cost for a specific utility. So we've got, for instance, SMUD and PG&E, if you live in that territory. On the right here, we've got NV Energy, PG&E to PG&E, if you have both right in the middle. This is just comparing the normalized cost. This is your utility cost. Gas is significantly cheaper, but in some areas it's an order of 10 or something like that, like an NV Energy. So if we look at that spark gap and sort of make some assumptions based on current rates for the mobile housing rates that are available, but broadly any rate, what is sort of the minimum COP you'd have to get to cost parity, not have bill increases. In SMUD and PG&E, you can install whatever the heck you want, and you're going to save money. You only need to hit like a COP of 1.5 to save money, going from gas on PG&E to electric on SMUD. If you're on the other end of the spectrum in NV Energy, you need a COP of like 7, which doesn't really exist to get cost parity, right? So the point I'm trying to make here is that in PG&E and SoCalGas, this one on the second from the right, it is basically impossible to get cost parity by electrifying, just by nature of how cheap gas is and how expensive electricity is in that particular territory. This is compounded by the fact that, like Chris mentioned, they don't have access to other rates like ELEC or that give you cheaper winter heating. They can't even get a winter baseline heating allowance because they're on a submeter. So everything we're stacking on is above baseline cost, right? So this is sort of the worst case possible in California, mobile housing on a master meter in PG&E and SoCalGas. We are not set up to win here in terms of current utility costs. And then, like I said, weatherization opportunities are somewhat limited. I'm going to skip Panelos just because of time, but the bottom line here is even with full electrification, we're using like 20 amps with these people. So 100 amps, 60 amps, doesn't matter. The thing that's really driving peak demand is cooking, which we've seen in other presentations. Everything else is peanuts. We could have selected whatever the heck we wanted and it wouldn't come close to 100 amps. So on costs, the only real way to reduce costs through electrification is plug-in solar. Rooftop solar, you might have 1x2s and older construction, can't mount anything to that. There's structural concerns. A lot of these people use like 2,000 kilowatt hours a year, so the economies of scale don't exist. We're getting like $14 a watt on some of these proposals. That's, absolutely bananas. That's never paying itself back, even if we could do it. So plug-in solar, closer to $4 a watt. In the case that we did with Resident 1, 800-watt system, 2 kilowatt hour battery, very small. That cut their bills in half compared to either pre-electrification or full post-electrification. We are curtailing because we're overproducing in the summer. Doesn't matter. It's pretty cheap. We don't have to go through the rigorous, permitting and all that nonsense. This is the way to achieve cost savings through electrification in manufactured housing. So if there's one takeaway, this is what I want. And call to action: support SB 868. Advocate for your local incentive provider to include mobile homes in funding streams. And as Chris said, these are programs for people. We serve people, not buildings. So questions? Otherwise, if you're at summer study, come find us on Tuesday at 4 p.m. and we can talk more about this stuff.